100 miles above the Soviet Union, a camera the size of a small car is photographing missile fields through a lens that can pick out something the size of a car from orbit. The pictures are the most valuable intelligence in the world, and there is no way to get them home. This is 1960. There is no digital sensor, no way to beam a high-resolution image down through space to a receiver on the ground. The photograph exists only as a chemical pattern on a strip of physical film, wound onto a spool, locked inside a machine that is moving at 17,000 miles an hour and cannot land. So, the people who built this thing solved the problem in a way that sounds, even now, like something invented for a film. They put the film in a capsule and they threw it back to Earth. They let it fall through the atmosphere behind a heat shield, deploy a parachute, and drift down over the Pacific, where an aeroplane was waiting to catch it in midair with a hook before it ever reached the water. The most advanced spy machine of its age depended, at the very last step, on a propeller aircraft snagging a bucket out of the sky. How that worked, and why the audacious low-tech ending was the only part that could work, is the subject of this. Start with the assumption almost everyone carries when they picture a spy satellite, because it is a modern assumption projected onto a machine that predates it. We imagine a satellite as something that sees and sends, that captures an image and transmits it instantly to a screen somewhere below. That is what satellites do now. It is not remotely what they could do then, and the gap between those two facts is the whole story. In 1960, the hard part of spying from space was never getting the camera up there, or even taking the picture. The hard part was that a picture, once taken, was a physical object, and physical objects in orbit stay in orbit. There was no way to convert a high-resolution photograph into a signal and send it home, not at the quality the intelligence demanded. So the entire design of the earliest reconnaissance satellites was shaped, from the first sketch, around a single brutal constraint. Whatever this machine photographed, it would have to physically deliver, by dropping it out of the sky and catching it before an ocean or a foreign farmer got to it first. The satellite was the easy half. The delivery was the hard half. And the reason the whole program existed at all was a single event that made the older way of spying suddenly impossible. Until then, the United States had photographed the Soviet Union from a high-altitude aircraft, flying above where anything could reach it, or so it was believed, until one of those aircraft was brought down over Soviet territory and its pilot captured. Overflight by aeroplane was finished. Too dangerous and too provocative to continue. The camera had to go higher than any aircraft into orbit where no one could reach it, and that decision created the delivery problem in the first place because a machine that far up cannot simply land. That inversion runs through everything. There are 4 things worth understanding to see how this machine actually worked, why the picture had to come home on film and could not be sent any other way. How you get a fragile capsule down through the fire of reentry and into the path of an aircraft. How the whole system was built to protect its secret even when the catch failed. And who the people were at every point in that chain, because more of this depended on human hands than you would ever guess. 4 systems, and behind all of them, a pilot with one pass to hook a falling bucket. We will take the program as it ran, from 1960 to 1972, under a cover story and a secrecy that held for decades, and every figure here is drawn from the record which was finally declassified in 1995. If this is the kind of thing you would give an hour to, the channel exists for exactly this, so consider subscribing before we go up. We start with the film, because the film is why everything else had to be the way it was. Understand the constraint, because it is the thing a modern mind refuses to accept at first. The camera aboard these satellites was extraordinary for its time. A panoramic instrument built by precision optical contractors, using a lens with a focal length of 2 feet, feeding onto special film manufactured by Kodak. And by the end of the program it could resolve objects on the ground just a few feet across from 100 miles up. That resolution is the whole point of the mission. It is what let analysts count missiles and measure launch pads and read the true size of the Soviet arsenal. But resolution like that means detail, and detail means information. And information at that density simply could not be transmitted. The technology to scan a high-resolution photograph, turn it into a radio signal, send it to the ground, and reconstruct it without destroying the very detail that made it valuable, did not exist in a usable form. There was an attempt at exactly that, a rival approach that would develop the film in orbit, scan it, and radio the images down. It was pursued and it was abandoned because the tech of the day could only process a small number of images that way and the quality was not there, so the picture stayed physical. It lived on a strip of film, and to be of any use to anyone, that strip of film, the actual object that had been exposed to light reflected off a Soviet airfield, had to be carried down out of orbit and placed into the hands of a person who could develop it. Hold on to the strangeness of that. The most sophisticated surveillance system on Earth produced its intelligence as a tangible thing you could hold, and could lose, and could drop. It made the problem of getting it home not a problem of signals and electronics, but a problem of physical delivery, of re-entry in parachutes and catching, the same class of problem as returning a person from space, and they were solving it at the same time anyone had ever tried to bring anything back from orbit at all. That is why the ending had to be what it was. The picture was cargo, and cargo has to be flown home, and there is a second physical problem hiding inside the first one, because a camera that can resolve something a few feet across from 100 miles up is a camera that cannot tolerate the slightest shake. At that magnification, the smallest wobble of the satellite smears the image into uselessness. Most early satellites were spin-stabilized, set turning like a thrown American football to hold their attitude, but a spinning platform is the last thing a precision camera can live on. So the vehicle that carried the camera, called a Gina, had to do something new. It held itself steady using horizon sensors to know which way it was pointing, and small puffs from cold gas thrusters to correct its attitude, keeping the whole platform pointed and still while it raced over the turning Earth below. The ability to hold a camera rock steady from a moving platform in orbit was as much a part of the achievement as the lens itself, because a perfect lens on an unsteady mount produces nothing but blur. The picture depended not only on the optics, but on the machine holding almost perfectly still at 17,000 miles an hour. So here is the inversion, the piece that stops people, and it is almost the reverse of how we think about high technology. The most futuristic machine of its era ended its mission with a method so low-tech it sounds like a stunt. When a satellite had exposed its film, it wound that film into a re-entry capsule, a small armored container the crews called a film bucket. The bucket separated from the satellite, fired a small rocket to drop out of orbit, and fell back toward the Earth behind a heat shield that took the ferocious heat of re-entry. At around 60,000 feet with the fiery part over, the heat shield was jettisoned and a parachute opened, and the bucket began to drift down slowly over a designated stretch of the Pacific Ocean near Hawaii. And there, waiting in the sky, was an aeroplane. A specially modified transport, at first a twin-engine C-119 and later a four-engine C-130, trailing a trapeze-like rig of hooks behind it from its open rear cargo door. The pilot flew at the descending parachute and snagged its lines with the hooks, and the crew winched the bucket up and into the aircraft in the air before it ever touched the sea. Read that again, because every part of it is true. A capsule of film returning from orbit was caught in mid-air by a propeller aircraft dragging hooks through the sky, and the reason it was done this way rather than simply letting the bucket splash into the ocean and picking it up by boat is the key to the whole design. Why go to the enormous difficulty of an aerial catch? Because the film was a secret, and a secret floating on the ocean is a secret that can be found by the wrong people. The aerial recovery was not showmanship. It was security. Catching the bucket in the air meant it never sat on the surface waiting to be discovered, never drifted where it should not, was in friendly hands from the moment it left the sky. And notice the margins these crews worked to. The recovery happened in daylight, in a window between roughly 500 and 10,000 feet, a band of altitude, and a slot of time in which the aircraft had to find, line up on, and hook a small target descending under a parachute over open ocean. Missed the pass, and the bucket kept falling toward the water, and the whole backup plan we will come to had to take over. The catch was the primary method, and it depended, at the decisive instant, entirely on a flight crew getting one approach right. Now look at how the capsule itself was built, because everything about it is a decision about surviving the journey and protecting the secret at the end of it. The bucket had to do several incompatible things at once. It had to be light enough to carry to orbit and back. It had to be tough enough to survive the heat of re-entry, which meant a heat shield, an ablative barrier that absorbed and carried away the enormous thermal load as the capsule slammed into the upper atmosphere. It had to slow itself, first with the heat shield's drag and then with a parachute deployed at altitude. It had to be findable, carrying a beacon and a flashing light so the recovery crews and ships could locate it. And it had to be, in the last resort, destroyable, which is the part that tells you what these people were really worried about. Because the one outcome the entire system was built to prevent was the film falling into the wrong hands. So the bucket was designed to float, if it hit the water, long enough for a ship to reach it, but only for a short time. Built into the base of the capsule was a plug made of salt, and if the bucket was not recovered within about 2 days, that salt plug dissolved in the seawater and the capsule flooded and sank, carrying the film to the bottom where no one could reach it. Think about the logic in that. The designers built a machine to bring the film home, and into the same machine they built a mechanism to destroy the film rather than let it be captured. The salt plug is the whole philosophy of the program, cast as a single humble component, a lump of salt doing the work of the most important security decision in the system, dissolving on a timer that no one has to set and no power source has to run. It is the same pattern you find in every well-made secret machine. The crudest, simplest, most passive part carries the heaviest responsibility, because the crude passive part is the one that still works when everything sophisticated has failed, and the capsule evolved as the program learned. The earliest satellites carried a single bucket, one return per mission, so the moment the film was dropped, the mission was over. Later versions carried 2 buckets, which changed the arithmetic of the whole flight. A satellite could now expose film, send 1 bucket home partway through its life, and keep photographing with the second, so a single expensive launch bought far more coverage, and a failed catch cost only half a mission rather than all of it. Even the power for all of this, the firing of the spin and despin rockets, the deployment of the parachute, the beacon and the strobe that let the recovery crews find the bucket, came from a single silver zinc battery, because a reentry capsule falling through the sky has no time and no room for anything that needs to be generated or maintained. Everything the bucket would ever do had to be stored in advance and triggered in sequence in the few minutes of its fall, and hold on to that salt plug. And that 2-day window, because there was a day when the catch failed and the backup failed, and the sea kept the film after all. Here is where the obvious risk turns out not to be the one that actually bit them. Ask what could go wrong with a machine like this, and the mind goes to the exotic dangers, the rocket, the re-entry, the fire. But the failures that actually embarrassed and threatened the program clustered around the most ordinary imaginable point. The moment the bucket came down somewhere it was not supposed to, and an ordinary person found it. In 1964, a Corona bucket came down not over the Pacific but over land, in a remote rural region of Venezuela, 500 miles south of Caracas near the Colombian border. There was no recovery aircraft, no Navy ship. There were farmers. They found this strange armored object that had fallen from the sky, and they did what anyone would do with a mysterious hunk of metal that nobody came to claim. They took it home. It was partially taken apart. Pieces of it were turned into household utensils and toys for the children. One man used the parachute lines to make a harness for a horse. A photograph of the capsule appeared in a local newspaper. By the time American agents traced it and collected the debris, the most advanced reconnaissance capsule in the world had spent weeks as scrap and toys in a Venezuelan village. Nothing in that chain was exotic. A recovery that went long, a capsule that came down where it should not have, ordinary people finding an extraordinary object and treating it as ordinary. And the change that came out of it is one of the most telling details in the whole program. After Venezuela, the capsules stopped being stamped with the word that had been on them, the classification marking, because that marking told the finder they had something secret and valuable. Instead, the buckets were relabeled with a notice, printed in 8 languages, offering a reward to anyone who returned the capsule to the United States. The design response to a security failure was not more secrecy, it was less. It was to stop looking like a secret and start looking like lost property with a reward attached, because a finder who wants a reward hands the thing in, and a finder who knows they have a secret might not. And then, a few years later, the harder version of the same lesson. In 1971, a bucket from the larger follow-on system came down over the Pacific as designed, and its parachute failed. The capsule struck the water at enormous force, on the order of thousands of times the force of gravity in the impact, and sank, coming to rest more than 16,000 feet down on the floor of the ocean. The salt plug and the sea had done by accident exactly what they were designed to do on purpose, put the film beyond reach. And rather than write it off, the Navy mounted what was then the deepest undersea salvage operation ever attempted, sending a deep submergence vehicle nearly 3 miles down to try to recover the capsule from the seafloor. The film, the physical object, was worth going 3 miles under the ocean to try to retrieve. And it is worth remembering how routine failure was at the start of all this, because it frames how hard the whole problem was. The first dozen or more missions returned no usable imagery at all. Launches failed, orbits were missed, cameras malfunctioned, recoveries were blown. It was not until the 14th attempt in August 1960 that everything worked in sequence and film came home from space for the first time. And that single successful mission returned more coverage of the Soviet Union than every previous spy plane flight combined. The machine that would go 3 miles underwater to recover one lost bucket had, only a few years earlier, failed 13 times before it succeeded once. That is how completely the whole enterprise still came down, in the end, to a strip of tangible film that could be lost. Which leaves the part of the system that was never engineered because it could not be, and on this machine it is a larger part than on almost any other. Everything we have described, the camera, the capsule, the heat shield, the parachute, the salt plug, does exactly what it was built to do and not one thing more. None of it decides anything, and crucially, none of it can complete the mission on its own. The whole point of this machine was to deliver a physical object into human hands, which means that at the two most important moments, the catch and the development of the film, a person had to do something no machine of the era could do. Consider how much of this ran on people. The recovery pilots, flying a heavy transport in a precise pattern over open ocean, trailing hooks with a single pass to snag a parachute descending through a narrow band of sky, and a crew in the back to winch the bucket aboard by hand. If they missed, the Navy ships and their crews racing to reach a floating capsule inside a 2-day deadline before the salt plug took it down. And once the bucket was in friendly hands, the people who mattered most and are remembered least, the technicians who developed that film, and the photo interpreters who then bent over it with loops and light tables, reading a shadow on an airfield as a new bomber, a scrape of disturbed earth as a missile silo under construction, turning a strip of exposed chemistry into the sentence a president would hear. A president of that era said that because of these satellites, he knew how many missiles the other side had and could sleep at night. That knowledge did not come from the machine. It came from the machine plus every pair of hands in the chain, the pilot and the winch crew and the film lab and the interpreter, any one of whom could drop the thing, expose the film, misread the shadow. The environment those people worked in was its own kind of pressure, not the confinement of a submarine, but the weight of it, an entire arms control posture resting on whether a crew caught a bucket and a technician developed a roll of film without ruining it. The honest pattern here is the same one that runs through every one of these machines, stated in an unusually pure form. The satellite was the miracle, but the mission was completed by people and the machine was built, from the very start, around the fact that at the decisive moment a human being would have to reach out and physically take hold of the intelligence, or it would be lost. So count the 4 again, quickly, the way they actually stack. The picture had to come home on physical film because nothing could transmit that much detail through space in 1960. The film was returned by dropping it through reentry under a heat shield and a parachute to be caught in midair by an aircraft before it reached the sea. The capsule was built to survive the fall, to be found by its own side and to destroy itself rather than be captured, with a lump of salt as its last line of defense. And the whole chain, from the catch to the developing tank to the light table, ran on human hands at every decisive point. 4 systems, and the 5th thing we named at the start now has a face. It is the pilot with one pass and the interpreter with a loop. Go back to the image we opened with. A camera 100 miles up with no way to send its pictures home. You can see it differently now. The audacious catch, the aeroplane snatching a bucket from the sky, was not a flourish added to a high-tech system. It was the only honest answer to the problem the physics handed them. The picture was a physical thing, so it had to be physically carried, and every clever part of the satellite existed to get one strip of film to the point where a person could take hold of it. The machine could photograph the world from space. It could not, on its own, tell anyone what it had seen. That last step was always going to be human, and the designers built the entire miracle around that fact rather than pretending otherwise. If you want to keep going inside machines like this one, the ones almost no one is allowed near, That is the whole reason this channel exists, so subscribe and stay with it. The next one stays in orbit but moves forward 2 decades, into the era when the film finally went away, and looks at the strange engineering problem of the machine that replaced the bucket and why getting rid of the parachute turned out to be far harder than anyone expected. And a question for the comments while you sit with this one. If the most advanced machine of its age had to end its mission with a propeller plane catching a bucket on a hook, was that a failure of the technology or the most elegant possible solution to a problem that had no other answer? And are those really different things? There is a real argument on both sides, and I would like to read yours. This video is for educational purposes only. It draws on published engineering literature, declassified documentation, manufacturer and service publications, and investigated peacetime incident reports. Where a figure is an outside estimate or has never been released, this is stated, and where practice varies between services or jurisdictions, this is noted. Nothing in this video is operational guidance.